ওকে, স্ক্রিন কি দেখতে পাচ্ছ?
Yes, sir.
So today we are going to discuss a new chapter, that is simple harmonic oscillation. তো শুরু করি আমাদের আলোচনা। What is simple harmonic oscillation, by the way? What is simple harmonic oscillation? Simple harmonic oscillation is a kind of two-flow motion. It is basically observed in a simple pendulum. For example, let's say you have a pendulum like this, and if you just displace it by an angle and put it here and just leave it, that's the big body, it's gonna move this way, and then it's reach here, and then it's come back again to the equilibrium position or initial position, move further back, and then this kind of to and fro motion is gonna continue. Okay, একবার এদিকে আসবে, একবার এদিকে যাবে, এরকম মুভ করতে থাকবে। So or maybe like let's say a spring. Let's say a spring. Again, in case of a spring, let's say this is the equilibrium position of a spring, and now what happens if you just pull this spring downward? You just pull it downward up to here, you say here, and then you just release it. So you get a release call dekba, it's gonna, this was the equilibrium position, by the way, or initial position when no force is applied on it. Then it's I start moving to this way, to position way, but it doesn't stop here, it's go further, maybe it's here, and then once it go there, it start again, it start going downward. Okay, so it's going to move once upward and downward. So again, this kind of motion is a simple harmonic motion. So what is the origin of this kind of motion? এই ধরনের motion আমরা কেন দেখতে পাই? Why this kind of object, they are giving us some kind of to and fro motion, একবার এদিক ওদিক এদিক ওদিক এই ধরনের করে মুভ করবে, right? So let me tell you guys what is the origin, why they move like this. The thing is, let's first tell you guys a position about, let's say this is the position, a position equilibrium position, and the natural tendency of every object is to maintain its equilibrium. সবাই তার equilibrium থাকতে চায়, let's say this O is its equilibrium position. Now once you displace it from A to A, once you displace it, like let's say you displace it and you move it from O to A, when once the object is at position A, এতে যখন সে থাকে তখন কিন্তু কি হয় দেখো, then it wants to go back to its equilibrium, সে তার ইকুইলিব্রিয়ামে ফিরে আসতে চায়, and that is why equilibrium ফিরে আসছে, that is why equilibrium restore করার জন্য the object apply a force on it, অবজেক্টটা তার ইকুইলিব্রিয়াম রেস্টোর করার জন্য একটা ফোর্স অ্যাপ্লাই করে, and because of that if you just release it, সে কি করবে, it start moving from A to O. এখন ইকুইলিব্রিয়ামতে যখন ওতে চলে আসলো, the object regain its equilibrium position, but still সে কিন্তু এখানে স্থির থাকে না, rather is move further. কেন এইদিকে কেন মুভ করে তারপরে বলতে পারবা? Why it moves from O to B? Let's say this position is B. This is because it has some inertia, that is kinetic inertia, and because of the kinetic inertia it starts moving to the opposite direction, and then when it is in position B, some force acts on it to regain its equilibrium once again, and because of this force again সে towards B এদিকে মুভ করে। তো আমরা একটা ফোর্সের কথা বারবার বলছি, what is that force? এই ফোর্সটাকে কি বলি বলতে পারবে?
Potential.
Okay, again আবার বলি, let's say this is a spring mass system. Okay, এখন this is the equilibrium position. Okay, this is the equilibrium position. এখন let's say তুমি এটাকে পুল করলা, let's say তুমি এটাকে extend করলা by some amount like this, এখন তুমি এটাকে এখানে নিয়ে আসলে টেনে। Okay, so this is the তাহলে তুমি করলা কি, you extend the spring by an amount of x, স্প্রিং এর ডিসপ্লেসমেন্ট হলো x ফর এক্সাম্পল। এখন x পরিমাণ যখন তুমি স্প্রিং কে এক্সটেন্ড করলা, ইকুইলিব্রিয়াম রেস্টোর, এখন স্প্রিং করে কি, স্প্রিং চায় তার ইকুইলিব্রিয়াম রেস্টোর করার জন্য, and to restore its equilibrium the spring always apply a force towards the equilibrium, or তোমার যেদিকে ডিসপ্লেসমেন্ট ছিল ডিসপ্লেসমেন্টের অপোজিটে, তোমার ডিসপ্লেসমেন্ট ছিল এদিকে, তো সে একটা ফোর্স অ্যাপ্লাই করে জাস্ট অপোজিট টু দিস, ওকে, টু দ্য ডিসপ্লেসমেন্টের অপোজিট একটা ফোর্স অ্যাপ্লাই করে, and this force is applied to restore its equilibrium, and that is why this is called restoring force. It is called restoring force. This is called restoring force. restoring force, Fr by F বলি restoring force. So in this kind of object a restoring force acts on it. তুমি যখনই অবজেক্টকে ডিসপ্লেস করো then a restoring force acts on it and the restoring force is directed opposite to the displacement. Displacement opposite. এই জন্য যখন তুমি এটাকে ডিসপ্লেস করলা because of the restoring force it starts moving and once upon a time again is go back to its equilibrium position. ইকুইলিব্রিয়াম পজিশনে চলে আসে এবং বাট এগেইন ইন ইকুইলিব্রিয়াম পজিশন সে কি করে আর থামে না বরং যদি বিকজ অফ দা কাইনেটিক ইনার্শিয়া ইট স্টার্ট মুভিং ফার্দার এন্ড দেন মেবি ইট রিচ হিয়ার ফর এক্সাম্পল। এখন যখনই সে এই ইকুইলিব্রিয়াম থেকে সরে গেল তখন কি হয় এগেইন সে চায় আবার কি করতে সে আবার তার ইকুইলিব্রিয়ামটাকে রিগেইন করতে চায় এন্ড দ্যাট ইজ হোয়াই অ্যানাদার রেস্টোরিং ফোর্স অ্যাক্টস অন ইট এবং সেই জন্য সে করে এই রেস্টোরিং ফোর্স জন্য সে আবার আগের পজিশনে চলে আসে মুভ ফার্দার এদিকে যায় বিকজ অফ দা কাইনেটিক ইনার্শিয়া এবং এখান থেকে আবার রেস্টোরিং ফোর্সের জন্য আবার ইকুইলিব্রিয়ামে চলে আসে সেভাবে করে টু এন্ড ফ্রো মোশনটা চলতে থাকে। সো মূলত তাহলে আমরা বলতে পারি দা অরিজিন অফ দিস কাইন্ড অফ মোশন অরিজিন অফ সিম্পল হারমোনিক মোশন ইজ বেসিক্যালি রেস্টোরিং ফোর্স basically the restoring force because of the restoring force this object oscillates and gives this kind of oscillation. এখন what is the nature of this kind of restoring force? So we can say that the restoring force depends on the displacement. তুমি একটি স্প্রিং হাতে নিয়েও দেখতে পারো যে the more you displace it the more force you feel on your hand by the spring. So spring or same thing happen for any kind of object. So the restoring force is basically restoring force is proportional to the displacement of the object x. And by the way, I should put a minus sign here. I should put a minus sign here. Why did I put a minus sign here? Because the direction between force and displacement are in opposite direction. Force direction যেদিকে displacement acts in the opposite direction. অথবা আমি বলতে পারি displacement যেদিকে থাকে restoring force তার opposite কাজ করে. That is why minus sign came here. And you can write this as F equal to a constant times x. So this constant is called a force constant. This constant k is a constant. And is called force constant. Okay, it's called force constant, and in case of a spring, this is called the spring constant. Sure. So this is the equation. By the way, this is the second. And now from second law, Newton's second law. I'm putting it in our class. Newton's second law. We know F equal to ma, force equal to ma, ma equal to force, or আমরা এভাবে বলি যে সাইন্টিফিক্যালি কারেক্ট যদি থাকতে চাই তাহলে আমরা লিখতে পারি ma equal to f, ma equal to sum of all the force acting on the object acceleration এই ফোর্সের জন্য হয় and which force acts on the object here? The force that acts on this object is the restoring force. The restoring force is acting here. So ma can be written as equal to minus kx, or you can say m. What is a, by the way? A is acceleration, and acceleration can be written as d square x over dt square is equal to minus kx, or this can be written as d square x over dt square equal to minus k over mx, or we can write this as d square x over dt square plus m over k x equal to 0. And by the way, here m is the mass of the object and k is a constant, that is spring constant or force constant. And let's name it m over k as w square, omega square. Let's name it omega square. So in this case, you can write this as like d square x over dt square plus omega square x equal to 0. So we get this kind of equation like this, and this is a differential equation. By the way, this is a differential equation, and this equation is called equation of motion or differential equation of motion for simple harmonic oscillation. আমি একটু পরে বলবো যে what's the importance of this equation. So আমি একটু বলি, so this is called differential equation of motion for simple harmonic oscillation. this is called differential equation of motion for simple harmonic oscillation. Simple harmonic oscillation is differential equation of motion, and this is basically a differential equation. Do you guys know what does differential equation means? The equation that involves differentiation is called differential equation. Like এটাও একটা differential equation হতে পারে, dx over dt plus omega t equal to 0. This is a differential equation. Or like g cube x over dx square dx cube dt cube plus 2 dx over dt plus 5x equal to 0. This is again a differential equation. The equation a differentiation থাকে like simplistically boli, then that is the differential equation, and every differential equation has an order. Highest power of differentiation is called the order of this equation. Like for example, the order of this equation is 1, this the order for this equation is 3rd, and for this is 2. This is a second order differential equation. This is called a second order differential equation. And what is the importance of this equation? The importance of this equation is that once we can solve this equation, if we solve this equation, this will give us the value of x. By solving this equation, we get the value of x or the displacement. Okay, solving it will give us x, and then if we differentiate this x, this will give us the velocity, right? And then 1/2 times mass times velocity squared, this will give us the kinetic energy. That means any motion related term like position, velocity, kinetic energy, or potential energy, or anything, যেটাই তোমার দরকার হোক না কেন, anything you can get once you know this equation and or from this equation. একটা oscillatory systeমের জন্য, by solving this equation we can get all the terms that are related to motion. Okay, so now then what do we have to do? We have to solve this equation. We have to solve this differential equation. So how to solve it? So solution of the differential equation. Of motion for, let me write it like SHM. SHM means simple harmonic motion. Okay, now the differential equation of motion is d square x over dt square plus omega square x equal to 0. This is the differential equation of motion, and we have to solve it. There omega square equal to k by m. Okay, now there is a standard procedure. This is a second order differential equation, and there exists a standard procedure to solve this kind of second order differential equation. But since you guys are not familiar with that differential equation stuff, আমরা একটা simple procedure follow করব to solve it. আমরা একটা simple procedure follow করব. এখন simple procedure-টা কি সেটা একটু বলি। তো আমরা অবজেক্টের এটা যদি solve করি, if you solve this equation, what do you get? By solving this equation, we can get the value of x. Displacement, right? Displacement that's vary. So let's see what is the nature or how the displacement vary for simple harmonic oscillation. If we plot this kind of let's say if I consider this as the initial position 0, and then তুমি যদি খেয়াল করো তাহলে দেখো এখানে 0, এটা যদি বলি যে that maximum displacement is 5, so একবার 0 থেকে +5 in one direction, and then it go back to 0, and then it go to the opposite direction. Let's say that if my downward is positive and upward is negative, then say -5. So it moves from +5 to -5. So it's like the oscillation is something like this displacement. Initially it was 5, sometime later it will be 0, and then it will go to -5, and then come back again to 0, or something like this, right? So this is how the displacement varies. Same again for here. Okay, so it is like kind of like sinusoidal wave or sinusoidal motion. অর্থাৎ এটা সাইন বা কস কার্ভের মতো পজিশনটা ভ্যারি করে। The position vary as sine or cos function like this. So আমরা কি করব to solve this thing? At first we will consider a solution. Let's say the solution. এবং দেখবো যে সেটা যদি এই ইকুয়েশনটাকে ভ্যারি করে, সরি স্যাটিসফাই করে, তাহলে বলব this is the solution. Let's say the solution. Let's say the solution for equation 1 is x equal to a sin omega t. Okay, let's say sin omega t, এটা আমি লিখলাম, and here a is a constant here, and by the way omega is also a constant. This is the solution. আমি ধরে নিচ্ছি এখন if this value of x satisfy this equation, আমি বলতে পারবো যে this is the solution of equation number 1. So what I can do, I can differentiate it twice. By differentiate it once, dx by dt will give us a, you guys know differentiation, right? Differentiation জানো তো বাবা? Hello.
Ji sir.
Yeah. So this is basically sine omega t. If you differentiate sine omega t, this will give you the cosine of omega t multiplied by omega. So omega into a is here, omega a. So dx over dt equal to omega a cos omega t, and d square x differentiated against once again. If I differentiate it once again with respect to time, this will give us d dt of omega a cosine of omega t. So basically it would be like left hand side is d square x over dt square equal to omega a is constant, so let's take it out, d dt of cosine of omega t, and means d square x over dt square is equal to omega a, and cosine of omega t means minus sine omega t, and multiply by an additional, if you differentiate omega t, this will give you an omega. So basically d square x over dt square is equal to minus omega square a sine omega t. And by the way, a sine omega t is equal to what? A sine omega t means x, so equal to minus omega square x. So finally, so we can write like d square x over dt square plus omega square x equal to 0. So this is exactly, this is equation number 1. So that means, and আমি equation 1 কে আমি কি করে আসতে পারি? I can come back to equation number 1 by using this equation 2. So we can say that x equal to a sine omega t is a solution of equation 1. So we can say that x equal to a sine omega t is a solution of equation 1 or the differential equation. And similarly, using, and at the same time, you can also show that x equal to a cosine omega t. Instead of a sine omega t, if you use a cosine omega t here, you will end up with the same equation. Or we can say that x equal to a cos omega t is also a solution. So there can be two type of solution for this equation. One can be x sine omega t or x equal to a cosine of omega t. Okay, এই দুটাই solution হতে পারে. So displacement there is a sine function or cosine function. যেটা খুশি তুমি সেটা ইউজ করতে পারো. Now আমি একটু দেখবো যে this equation, so the solution for simple harmonic, so the displacement for simple harmonic motion is like x equal to a sine omega t, right? So what does a means here, or what does omega means here? What is a, what is omega, or something like this? So I mean, you need to দেখি how the displacement x varies with time. If I want to plot a graph like this, here is my x, so here is my time, there is my time, and there is my x is here, so it should be like this. Very this. না ভাস্করকে দেখাও, ও জিহাদ ওইটা ইউজ করবে না, ঠিক আছে? আমি ক্লাস নিচে পরে কথা বলবো, মানে ভাস্কর ইউজ করবে, মানা করে দাও, বলে আমার সাথে পারমিশন নেওয়ার জন্য। Okay, so sorry. So this is the position versus time graph. This is the position versus time graph. This is how the position varies with time. And now if you just have a look here, sine function has a maximum, the value of sine function, it varies. কত থেকে কত পর্যন্ত ভ্যারি করতে পারে sine function? Sine has a maximum value of +1 and a minimum value of -1. So if I say the maximum value of displacement, আমি যদি ম্যাক্সিমাম ভ্যালু অফ ডিসপ্লেসমেন্ট জানতে চাই, দ্যাট ইজ লাইক এক্স ম্যাক্স, এটা কত হবে বলতো? a ইনটু ম্যাক্সিমাম ভ্যালু, a তো কনস্ট্যান্ট, a ইজ এ কনস্ট্যান্ট হিয়ার, সো ম্যাক্সিমাম ভ্যালু অফ সাইন ফাংশন, maximum value of sine function is 1. So x max equal to a, or in other word I can say a is the maximum displacement. So a is the maximum displacement of the oscillatory object. So the এখানে যে কনস্ট্যান্টটা ছিল a is the maximum displacement of the oscillatory object and is called displacement. Harmonic oscillation and is called amplitude. এটাকে বলে amplitude of oscillation. A is amplitude of oscillation. Now let's move to here, omega t. What is omega or something like this? So তুমি একটু দেখতে পারো, this kind of motion, this is a kind of periodic motion. Simple harmonic oscillation is kind of periodic motion. What does periodic motion means? That means after a certain time, which is the time period, after a certain time, the motion after a certain time, the motion okay, the object come back to its initial position. At a certain time period পরে সে তার কি হয়, অথবা the motion repeats itself after a certain time period. After a certain time, the motion repeats itself, and this is called a time period. This is called a time period. So this is a oscillatory motion, is a periodic motion. Oscillatory motion, as you know, oscillatory motion is periodic motion. And let's say that the period for this particular case, the time period is t. What is time period? Time period is a time after which the motion repeats itself. Right? এখন একটু খেয়াল করো, at time t equal to 0 তে, let's say at time t, so the displacement here x is equal to a sine omega t, right? Displacement. এবং এটা হচ্ছে যে কোনো একটা টাইম ধরো, মনে করো এই টাইমটাই ধরলাম, এই টাইমে ডিসপ্লেসমেন্ট হচ্ছে এটা x equal to a sin omega t, এবং after t time period পরে, right, after the time period t, the motion will repeat itself, অর্থাৎ পজিশনটা সেম হয়ে যাবে। তাহলে আমি এটা কি লিখতে পারি, equal to a sin omega t plus t. Is it okay? আমি কি এটা লিখতে পারি, একটু বলো তো। এটা কি বুঝতে পারছো? হ্যালো হ্যালো, আমি প্রসিড করব? তোমরা কেমন কথা শুনতেছো? হ্যালো হ্যালো,
স্যার শোনা যাচ্ছে?
বুঝতে পারছো? যা মানে বুঝতে তো সমস্যা হচ্ছে না। আচ্ছা ঠিক আছে, আমি এটা ধরে নেই যে তোমরা বুঝতে পারছো, এবং যদি তোমাদের বুঝতে অসুবিধা হয় তাহলে আমাকে প্রশ্ন করো। So here is the thing. So x equal to a sin omega t, and again for sine function or sine, this kind of sinusoidal function, sine function or cos function has a time period of theta. Sorry, 2 pi, because every sine function or cos function after elapsing an angle of 2 theta, like এখানে একটু প্লট করে দেখাই যে if this is my 0, after 2 pi it's gonna repeat itself, sine function or cos function, okay, 2 pi per, like if this is my pi, so this will be like twice pi plus pi, 3 pi. So এটা আমরা জানি, we know this thing. So what you can do, we can write, so also a sin omega t, so a sin omega t can be written as a sin omega t plus twice pi, right? এটা আমি লিখতে পারি a sin omega t means a sin omega t plus twice pi. So now if you just have a look at these two equations, you can see that the left hand side is same. In both cases the left hand side is same. That means we can say that the right hand side are equal. So we can write a sin omega t plus capital T equal to a sin omega t plus twice pi. Okay, that means need to our figure type draw for here. This will help me later. So this is my picture for x versus t graph. Okay, so what he wrote in the previous pages is like a sin omega t plus a sin omega t plus 2 pi. A and a gonna cancel each other, so I left only with a sin omega t plus t equal. I just a or a gonna cancel, right? আমি পাবো I left sin omega t plus capital T is equal to sin omega t plus twice pi, right? And sin function আমরা জানি if sin a equal to sin b, if my sin a equal to sin b, then I can say okay a equal to b, right? So we can say from here that omega t plus capital T equal to আমি একটা ছোট্ট ভুল করেছি, এখানে একটা ছোট্ট ভুল করেছি, sorry my bad. Actually this should be for time period. When I'm writing it here, it should be like omega t plus capital T. It should be omega t plus capital T. Okay, okay. This is right. Okay, so omega t plus twice pi t plus capital T. Okay, because time এখানে টাইমটা হচ্ছে if this is my time small t, and this time would be t plus capital T, and omega is multiplied with the time, so here omega is multiplied with the time. So আমি start again. Omega t plus capital T, that's this thing, and since both of them are argument of sign, so argument are same, so omega t plus capital T equal to omega t plus twice pi, or we can write omega t plus omega capital T equal to omega small t plus twice pi. So this omega t and omega t are going to cancel each other. Omega t and omega t are going to cancel each other, so you left only with omega capital T equal to twice pi. So basically omega equal to twice pi over t. Twice pi over t, and by the way we know 1 over t is equal to what? 1 over t equal to frequency, so we can also write omega equal to 2 pi times f. So basically omega has the unit of frequency multiplied by twice pi. That's why omega যে constant আমরা বলেছিলাম যে omega equal to root over k by m, this is called angular frequency. Omega is frequency, omega is called angular frequency. That is frequency multiplied by some angle, angular frequency. And by the way, from here we can see there exists a relation between time period and frequency, angular frequency. We can write like omega equal to twice pi over time period, or we can say t equal to twice pi over omega. So t equal to twice pi over omega, or omega means root k by m, so t equal to twice pi into square root of m over k, right? So this is how we can find out the time period of an oscillatory object. Here m is the mass of the object and k is the force constant. So we need to know the force. Once we know the force constant, we can find out the time period. Okay, is it clear, guys?
Yes, sir.
Let's discuss a little bit more about the energy of an oscillatory system. So total energy for oscillatory system, or for any system, the mechanical energy, that is equal to the sum of kinetic plus potential energy. So energy equal to kinetic energy plus potential energy. or say let's say energy denoted by E, kinetic energy is K, then kinetic energy, let's name kinetic energy as T, because K is already used as force constant. Kinetic energy is T plus potential energy is U. Okay. So what I want to know, I want to know the expression for the total energy. So the displacement for simple harmonic oscillation, for simple harmonic oscillation, displacement x is written as, let's write a sine omega t, right? A sine omega t. Okay. Also, one thing, একটা জিনিস আবার একটু বলে দেই, এটা অবশ্যই একটু বলা উচিত ছিল আমার। So again, here I need to again lecture to the solution of the Schrodinger, like not Schrodinger, solution of the simple harmonic differential equation for the simple harmonic oscillation. আমরা কিন্তু often time আমরা কিন্তু এটাও লিখতে পারি, the solution x equal to তুমি যদি এরকম লেখো a sin omega t plus a particular thing a theta, or x equal to a cosine of omega t plus theta, there should also be a solution. Also এটাও সলিউশন হতে পারে, হ্যাঁ, x equal to a sin omega t plus theta, এগুলো সলিউশন হতে পারে, যেটা তুমি একটু বাসায় ট্রাই করো, হ্যাঁ, a cos omega t, a sin omega t, অথবা a sin omega t plus theta, এই জিনিসটাও আমরা দেখতে পারি যে these are also solution of like differential equation for simple harmonic oscillation বা displacement কে এভাবে লিখতে পারি। So what is the term here? আমরা জানলাম যে a is the amplitude, omega is the angular frequency, and what is theta, by the way? এটা আমি একটু এখানে বলি। So if I write my displacement as x equal to, if we write x equal to a sine or cos whatever omega t plus theta, in this case this theta is called epoch angle. Is basically determine the initial angle of the system, initial angle of the motion. So it can be 0, it can be 10, it can be 5 degree. It just depends from where you are starting. And at this term, these are called phase angle. Omega t plus phi, these are called phase angle. So using this equation is more preferable, okay? Sin omega t plus phi or cos omega t phi, it am useful. So let's say the displacement is x equal to a sin omega t plus phi or theta. Okay, this is my displacement. Now we know kinetic energy. We know that kinetic energy equal to kinetic energy T equal to 1/2 times mv square. Okay, mass time velocity square is my kinetic energy. So if we know the displacement is this, then velocity can be written as dx over dt. That is equal to a sin omega t plus phi plus theta. Okay, so okay, no, I have to differentiate this guy. Differentiate this. Okay, so this is the displacement. So velocity will be equal to a is constant, it will come outside, and we already did this thing, a omega cosine of omega t plus theta. Okay. So this is the velocity. So if we replace this velocity here, so this will be t equal to 1/2 times mass times cosine of omega t plus theta whole square. So my kinetic energy T equals 1/2 m. Oh, I made mistake, guys. There should be a omega. A omega velocity is a omega cos omega t plus theta. A omega cosine of omega t plus theta whole square. So this should be like m a square omega square cos square omega t plus theta. This is expression number 1. And let's say this is equation number 2. So I know the kinetic energy. Now what about the potential energy? So now we know that potential energy is defined as negative of work done. Potential energy is negative of work done. So potential energy equal to U equal to minus W. And work done for variable force is F dot dx, যেটা আমরা হয়তো কোন ক্লাস দেখেছি, F dot dx. This is how the potential is defined. F dot dx. Okay. So now your potential energy, this is the definition for potential energy, F dot dx. Okay. So here for now, for the time being, we know that for simple harmonic oscillation, force is equal to minus kx and times dx. So U equal to minus minus plus, and k is constant. It will come outside, k integral of x dx. So if we this by kx, if I integrate x with respect to x, this will give me x square by 2. So k x square by 2. So this is the kinetic energy. This is the expression for kinetic energy. U equal to, sorry, this is the expression for the potential energy. U equal to kx square by 2, and I know x equal to a sin omega t plus theta. So U equal to 1/2 k x square, and if we substitute the value of x here, x is what? X is a sin omega t plus theta whole square. So my potential energy equal to 1/2 k a square sin square omega t plus theta, right? Kx square omega square t. By the way, what is k means? This is my kinetic energy, and also I know this is the kinetic energy, and also we know what potential energy was. What potential energy was 1/2 m omega square a square naki what again m omega square a square, right? Okay, sin square cos square omega t plus theta. This is my, so let's say this was my equation number 3. This is my equation number 2. By the way, k is defined as omega square is defined as what? K by m. So we can write k equal to m omega square. K equal to m omega square. So these things m omega square can be written as k. So my kinetic energy T equal to 1/2 k a square cos square omega t plus theta. Is 2. So then we can write E equal to T plus U. So this is basically 1/2 k square sin square omega t plus theta plus 1/2 k square cos square omega t plus theta. So see here, sin square omega t plus theta, can half k square is common term. If we take the half k square common, then I get sin square omega t plus theta plus cos square omega t plus theta. That is equal to 1. So we can say energy equal to 1/2 k a square. And by the way, here energy k is a constant and a is amplitude, that is also a constant. So basically the energy or total energy is constant for simple harmonic oscillation. And if I plot the if I want to plot the energy as a function of time, okay, so this is the energy. So this should be the potential energy. Potential energy is kinetic energy is cos square theta, right? So this is the kinetic energy. Let's say this kinetic energy, and this should be the potential energy. This should be potential energy. Okay, this is potential energy. Yeah. And my total energy is this. This is the total energy. Okay, so this is how the energy varies during simple harmonic oscillation. This is how the energy varies during simple harmonic oscillation. Do you have any question, guys? No question, right? No question, nothing. So if you guys have no question, we can move forward with the problem. Allow me some time, okay? Give me some time. Let me open a book. So, okay. Let us try this math here. Can you see the slide? Slide দেখতে পাচ্ছ?
জি স্যার দেখা যাচ্ছে।
Yeah. So it is asking us what is the maximum acceleration of a platform that oscillates at a amplitude of 2 centimeter and frequency of 6.6 hertz. Frequency of 6.6 hertz and amplitude of 2. So this is my amplitude A and this is my frequency F. CF. Therefore, in hertz bola ase hertz is the unit of F, and omega is basically when omega means angular frequency. Okay, omega means angular frequency. Omega means angular frequency. Okay, so and F means frequency. Okay, so এখন amplitude and frequency bola ase what is the maximum acceleration? Maximum acceleration bolte bolche. What is the maximum acceleration? Then maximum acceleration, how to find out the maximum acceleration or maximum velocity? Oftentimes we have to use these things. So one thing is the displacement. If you calculate the displacement, let's discuss a little bit more before solving this math. Displacement is defined displacement, so let's say equal to x equal to a sine omega t plus phi, right? Then velocity কি হবে? Velocity v equal to dx over dt. So that is basically ddt of a sine omega t plus phi, and we already did this differentiation a number of times. So velocity is basically equal to omega a cosine of omega t plus phi or sine. Okay, now see here again. Here omega is what? Omega is a constant. Omega is a constant because omega equal to square root of k by m. K is a constant, m is a constant, omega is a constant, and a is the amplitude of oscillation. A is also a constant. A is constant, but cost function can vary. Cost function can vary, right? Cost function vary করতে পারে। কিভাবে vary করে? This is how the cost function vary, right? So this is my cost function. Cost function vary করে হবে। দেখতে পাচ্ছ তোমরা ছবিটা? So cost function varies like this. Cost function, right? The maximum value of cost is +1 and minimum of -1. Then velocity will be maximum when cost function has a maximum value. Velocity will be maximum when cost function has a maximum value. Then velocity maximum equal to কি হবে? Maximum velocity equal to omega a times maximum value of cosine, that is equal to 1. So V max equal to omega a. Okay, maximum velocity. But they are not asking for this. They are asking for the maximum acceleration. Maximum acceleration. Okay. They are asking for the maximum acceleration, right? So to help, we know that velocity is what? Velocity is omega a cosine of omega t plus phi. So acceleration is equal to what? Acceleration means dv over dt. This is ddt of omega a cosine of omega t plus phi, right? So acceleration is basically equal to, if you differentiate cos omega t, you will get a omega. So minus omega square a sine cos k differentiate minus sine square omega t plus phi. And same again in this expression for the acceleration. Let's write acceleration. In this expression for acceleration, you can see omega is a constant, a is a constant. You have a sine function over here. So acceleration will vary with the sine function. Sine function is সাথে vary করবে. Sine function এর value যখন minimum হবে, তখন acceleration will be maximum since a minus is involved here. So how the sine function vary? Sine function vary this way, and the maximum value of sine function is +1, and minimum value of sine function is -1. So a will be maximum when I put the value of sine function is -1. So maximum value of a max equal to minus omega square a times -1. So a max is basically equal to omega square a, right? This is my a max. And by the way, how the omega is relating to the omega, কিভাবে করে, how it is, what is the relation between omega and frequency? সেটা তোমরা already জানো, তাই না? আচ্ছা, now let's solve the math. Solution of 3. Solution. What they are asking for, they are asking for maximum acceleration, and this is the expression for the maximum acceleration, right? So a max is basically equal to omega square a. Omega means what? Omega means 2 pi f. আমরা একটু আগে define করেছি omega equal to 2 pi f. So 2 pi f whole square times acceleration, time amplitude. So f is given here. F is 6.60 and a is 2.2 centimeter. So a good practice is to convert it into meter. So my acceleration is here. Amplitude is 2.2 centimeter. That is equal to 2.2 divided by 100, right? So 0.022 meter. So a max will be equal to 2 pi times 6.6 whole square into 0.022. So this should be answer. Clear? Is it clear, my dear students? Hello.
Yes, sir. The
Okay.
answer
So,
is 37.8.
okay. By the way, আমি একটু জিনিস একটু বলি. When you are using pi here, when you are using the value of pi here, you have to use put the value of pi in radians. Radians use radian. Okay. So don't use the pi in degree. Radian use করেছো তুমি? Hello. যে করলা অ্যানসারটা বলেছো radian. Pi should be in radian. So I hope that's all for today. I'm going to stop here, and I'm going to stop the share. Yep. So let me take the attendance. Okay. So
স্যার আমাদের অ্যাটেন্ডেন্স নেওয়া বাকি ছিল।
হ্যাঁ, অ্যাটেন্ডেন্সটা নিব, এখনই নিব। সেটাই আমি আমার অ্যাটেন্ডেন্সের শীটটা ওপেন করছি। এরিনা তাহনিম, এরিনা কি আছে? এরিনা?
Yes, sir.
And then Eram Ehsan. Eram Ehsan absent. Okay. And Nafia binte Korim. Nafia. Is she here? Nafia?
Yes, sir.
Okay, very good. And then Trisha, Rehana Kausar, Trisha. Rehana Kausar absent. Mahajabin Mariam, Mahajabin Mariam, Mahajabin absent. Nahida Sultana absent. Nusafarin Bijeta, Nusafarin absent. Sadia Afrin, absent. Imama Korim, Imama.
Present.
Thank you. Samara Farhin, Ahmed Sneha, Samara Farhin. Yes, is present. Sheikh Ashraf Hussain Habib, Ashraf Habib absent. And then Tazneen Asgori, Tazneen Asgori সেটা ছিল বোধহয়। Anyway, absent. Tazneen Asgori absent. And then Munem Shahriar,
Present, sir.
Thank you. Rufaida Anam,
Yes, sir.
Thank you. Jyotirmoyi Aditya, Jyotirmoyi absent. And then Ashikur Rahman Safat, Safat is also absent. Prashanto Shen absent. Shahama Arusha.
Present, sir.
Thank you. Tanjid Nabil.
Present, sir.
Thank you. And then Humaira Siddiq.
Sir, chat box to this.
আচ্ছা ঠিক আছে। কানিস ফারজানা রিকি, absent.
স্যার আমি চ্যাট বক্সে লিখেছি ও প্রেজেন্ট।
Thank you. Noshin Mufarrat,
Present, sir.
Thank you. Marjana Julfa,
প্রেজেন্ট স্যার।
Thank you. Lamia Ali, Pongti. Lamia Ali, absent. And then Tahmina Anjum, absent. And then Urbi, Nudrat Mufarrat, Nudrat Maimuna Urbi, absent. And then Farhana Jahan Aka, absent. Sanjid Muhammad Tawhid Tahmid, absent. Sumaya Rahman,
Present, sir.
Sumaya present. And then Faisal Hussain,
Present, sir.
Tasnim Sania, absent. Tanvi Azmi Dola, absent as well.
Present, sir.
Acha Dola present, okay. Nusrat Jahan Anita,
Present, sir. Sir, আমারটা কি শোনা যাচ্ছে? জি।
okay. Anita present, Dolao present, তাই তো? Payal, Momota Afroji Payal, thank you. Payal. And Mariam Nur Momita absent. কারো অ্যাটেন্ডেন্স বাকি আছে কিনা?
স্যার সামারা ফারহিন আহমেদ স্নেহা কি প্রেজেন্ট দিয়েছেন? ও প্রেজেন্ট ছিল।
হ্যাঁ দিয়েছি।
মাইক্রোফোন
সামারা ফারহিন প্রেজেন্ট। সো ঠিক আছে, আজকে এই পর্যন্তই থাকলো। ভালো থেকো সবাই, ইনশাআল্লাহ আগামী দিন দেখা হবে। টেক কেয়ার।
আসসালামু আলাইকুম।
ওয়া আলাইকুম আসসালাম।